Hello, everyone. Mr. Minnick is my name. Math is my game. Today, I'm joined by my sixth period Algebra II class. They just found out that they're going to be 2 days ahead of the other class because we're switching. And I think they're excited about it. They are cooler than you guys because they are. All right, Chapter 2, Section 4. More about linear equations. Well, we didn't even study linear equations. Well, we kind of did, didn't we? Remember the first week of school when we talked about graphing lines? We did talk about that. All right. So the objective today then for this lesson is to be able to write an equation of a line given its slope and a point on the line. That's what we need to do by the end of this lesson. Oh, man. Do you need to know the Common Core content standards? That students will write a function defined by an expression? No, that's just for my record-keeping purposes. So, more about linear equations. We ready? I really like to reminisce about prior jobs that I've had. Some of you might know that I used to work at Radio Shack. Did I mention that in here before? I was a salesperson at Radio Shack. Some of you might know that I was a direct care provider. For MR/DD adults. Did I mention that? If you don't know what that means, it means Hattie Larlam's in Mantua. Some of you have probably heard of that place. Mentally retarded, developmentally disabled children go there for workshops and whatnot. I worked at a residential home with mentally retarded, developmentally disabled adults. Okay. I also was a gas station attendant. Are you going to be quizzed on what jobs I've worked? Well, there might be a trivia question about it at some point. And then I was also a parts runner at a garage. And later on at the same place, I ended up becoming a mechanic. And then the last job I had before here, I worked for a company called Shade Tree. I was more or less their sales retail manager. More or less a sales retail manager. Anyway, of all those jobs that I've had, and I actually have another couple more jobs now that I do. I work on four-wheelers on the side for a little bit of money, and I paint fences. So if I ever come in wearing shoes that are green and white, it's because I've painted with them. Actually red and white. But anyway, of all those different jobs that I've had, can anyone take a wild guess as to which one was the most satisfying? Yes. The direct care provider. Actually, no. And I don't mean any disrespect to the clients there, but that was the toughest job I've ever had in my entire life for a number of reasons. What do you think? The mechanic. Absolutely, without a doubt. When I was a mechanic, that was the most satisfying job. And the reason being is when you're a mechanic, something comes to you, it's broken. You do some things, and it leaves in theory, it's fixed. You did a good job, you fixed it, and you have instant feedback as to whether or not what you did worked, right? Now, providing direct care to MRDD adults, imagine a 37-year-old man with the social skills and brain function of a 5-year-old or maybe a 4-year-old. And day after day after day after day, you're doing the same thing with this person, helping them shave without cutting themselves, helping them eat without choking on their food. Very little slow progress is made, if any, and it's kind of frustrating. Working in sales at Radio Shack, I was trained to lie to people to make a living. I was trained to lie to people. I'll tell you more stories about that later. Being a gas station attendant, I tell you what, anybody that works in fast food, I have a lot of respect for you. Working with people, it sucks. People suck. I don't mean to sound mean, but you know what I mean. People disrespect you. They don't care about you. You know, when you're a mechanic, somebody brings their car to you because it's broken, and some people that bring their car to you, they suck, and they're going to get an attitude with you and, you know, say that you messed their car up. But anyway, so why do I mention all this? Well, I mention all this because being a mechanic is kind of like being a math student. Being a mechanic isn't about being able to do the job necessarily. It's about having the right tools. Having the right tools in your toolbox. And I know that was a real big lead into this. But there's some tools about lines that we need to know. We need to know y equals mx plus b. You have to know that. If you don't know that, you're not going to be able to do any of the upcoming work. Maybe they're going, the book's authors, whoever's writing the homework, maybe they're going to give you 2 points and you're going to need to know the slope formula. So here's another tool that is worth knowing, worth having in our toolbox. Now, jealousy is not a very admirable trait, but I got to go on record and say I'm very jealous of my friend TJ. He has 2 Snap-on toolboxes that are worth more than my house. Just the boxes, let alone what's in them. He has a Snap-on toolbox that's as tall as this filing cabinet and about the distance from the filing cabinet to the smartboard long. He has 2 of them. Anybody ever buy a Snap-on item, a Snap-on tool? You know, you can go to Sears. You could go to Sears and you could buy wrenches that go from 7/16 of an inch up to 3/4 of an inch, and it's about $35 for a set of combination wrenches at Sears. The same wrenches from Snap-on will run you $500. A lot of money. A lot of money. Anyway, there's a couple other tools that we're going to need to know. We're going to need to know AX plus BY equals C. There's another one that's Y minus Y1 equals M times X minus X1. Now there's a little variation. Sometimes we have to take a tool and we have to bend it a little bit. Wasn't there a slogan a while back, bend it like Beckham? I don't even know what that means. Is it something about kicking a soccer ball so it curves or something like that? Is that what that means? Okay. Anyway, if we were to modify this one, it could kind of give us this other one that says B could be found by taking Y minus MX. Some of you might like to use that from time to time. Sometimes that's pretty handy. My friend TJ that has all those tools, he actually takes some and makes his own tools. There's some tools that cost so much money or that don't exist, and he has to make his own tools sometimes. He's a mechanic for a living. He works for Cummins. So being a math teacher, there's some tools that I like to take, and I like to rework, and I like to make my own tools, and you'll never see this in any textbook. But y could be thought of as negative a over bx plus c over b. Okay, that's a variation of this tool also. Okay. And if you understand the way a tool works, it can save you a lot of aggravation later down the road. A lot of aggravation later down the road. Anybody ever try to change the hose clamps on a radiator before with those little 2 tabs on them? And you put a pair of vice grips on them and the vice grips just fall right off? They actually make a tool that fits those. Anyway, any questions so far about these tools? Okay. So let's go to example number 1 then. Example number 1 says a line passes through the point negative 5, 2, and the slope is 3/5. And they, the authors of the book, they want us to write the equation of this line. So a line passes through negative 5, 2. I like to sketch a picture of this. A line passes through negative 1, 2, 3, 4, 5, negative 5, 2. So a line's going to go through this point, and the slope is 3/5. Rise and run. So rise 3, 1, 2, 3, and over 1, 2, 3, 4, 5. Actually, that would put us right over here. So the line's going to kind of do something like this, and they want us to write the equation of it. Now, I don't know how far up that was necessarily. Maybe I could count. Maybe I could. Actually, we could because of the slope. Dude, there's really not much to do here, is there? Hold on a minute. This was negative 5, 2. We went over 5. We went over 5 this way, right? Which puts us right on that axis. And how far up did we go? We went up 3, right? So somebody said it. Where's that? What's the coordinates of this point? 0.05. Oh, dude, that's awesome. We don't even have to do any work now. We don't have to make any calculations. All we got to know is of those tools, what tool are we going to use here? What's the right tool for the job? Y equals mx plus b. Now in y equals mx plus b, if you don't know any better, you know that m stands for what? The slope, and the slope was given of 3/5, right? And you probably know what the b is. The b is the y-intercept. In other words, it's the value of y when x equals 0. So looking at our graph, dude, this is so awesome. This is awesome. Look at that. That's our y-intercept, isn't it? And our slope's given. So the answer is a piece of cake. Y equals what? Yeah. 3/5 x plus 5. Bam. Like a boss. Like a boss. Anybody else say boss like that? Like a boss. It's spelled B-A-O-U-S. Like a boss. Maybe 2 S's. Now, I know what somebody was thinking. Somebody was thinking, well, dude, isn't this where you got to use point-slope form? Because the book just talked about point-slope form. Do you have to use point? Well, you could. You could if you really wanted to. You could take y minus y1. Y minus 2 equals m times x minus x1. You could if you wanted to. So that's y minus 2 equals 3/5 times x plus 5. So that's y minus 2 equals 3/5 x. What's 3/5 times 5? Oh, man. We suck at fractions. We hate fractions. 3/5 times 5 is 3 times 5 all over 5. That's 15 over 5. So that's what? That's 3. So that's plus 3. And then when we add the 2, we get y equals 3/5 x plus 5. Dude, we got the same thing, I know, and we didn't even have to do any work. A picture is worth 1,000 words, isn't it? My friend's a mechanic, and one of the coolest tools that he has is the same thing that plumbers use. Those cameras. You ever see plumbers use a camera? You know, they have no idea what's wrong with the pipe unless they stick a camera in there and they look at it. And sometimes in math, if we draw a picture of it and we can look at it, we know what's up. I think the answer is going to be under this box if I move it. Yep. Y equals... oh, they left the answer in slope-intercept form, or in point-slope form, I mean. I guess he could have done that too. Never thought to do that. Are there any questions about this first example? Any comments, concerns, short debates, long debates? Anybody want to know the meaning of life? The meaning of life is not the number 42. My personal opinion about the meaning of life is that in life there's this 4-letter R word that's real important. Anybody know what the 4-letter R word is? Somebody said it. Did you say rope? Not rope, but it shares 3 letters with rope. Not rose. Anybody here take psychology? In psychology, you're going to learn about the Zimbardo prison study. The Zimbardo prison study, what they did is they took a bunch of college students and they put them in a prison. And they said, okay, some of you are going to be guards, and some of you are going to be prisoners, and some of you are going to be the warden. And this study was supposed to take place for 10 months, and you know what happened? They had to shut it down after about 5 to 6 weeks. Normal college students, not prisoners, not felons, not prison guards, normal, everyday college students who volunteered to take part in this study. They were paid well to participate, by the way. Within the time that they shut it down, they were rioting. They were doing the unspeakable things that prisoners do to one another. They were trying to escape. It was awful. People assume whatever R-O-L-E role they have. People assume whatever role they have. And my opinion on the meaning of life is to find out what your roles are and to fill those roles as well as you can. Whatever that means to you. So who are you? What are you? You're a daughter. You're a son. You're a nephew. You are a student. You are an athlete. You are a... If you're anybody in here operate a motor vehicle? If you're operating motor vehicles, I would rather that you drive. So when you're in your car on the roads, on the highways and byways, please drive and don't operate a motor vehicle. There's a big difference. Okay. Let's go back and look at this problem 2. This is a whole new problem. Oh man, a line passes through 3, 2, and 5, 8. What's the equation of this line? I wonder if the picture trick would work this time. I wonder if that would work every time. I don't know if it would or not, but we can find out. The line passes through the point 3, 2. 3, 2. There's one point. The other point's 5, 8. 5, 8, 5, 8. So if we just did that, maybe we could save ourselves this hassle. Maybe we could save ourselves the hassle of trying to find this y2 minus y1 over x2 minus x1. Maybe we could save ourselves the trouble of saying, well, the slope is 8 minus 2 over 5 minus 3, which is 6 over 2, which is 3. Maybe we could have done that. Maybe we could have looked at the graph and said, okay, I go up 1, 2, 3, 4, 5, 6, and over 2. Up 6 over 2, so my slope is 3. Anybody think they know the equation already? Anybody think they know? You want to see some of the crap that some people try to pull? Here's the weak stuff that some people try to pull. They try to say that y equals 3x plus 8. Tell me why it's not 8. Yeah. Because 8 isn't on the x or on the y-axis. The y-intercept is the value of y when x is 0. So a lot of people are looking for shortcuts. A lot of people want this to be the y-intercept. I got news for you. It's not. A lot of people want this to be the y-intercept. I got news for you. It's not. So you have to somehow find the y-intercept. Now, if you wanted to rise and run again, could we rise and run again and find our y-intercept? Heck yeah, you could. Nobody said you have to rise and run the one way only. Can't you rise and run the other way? Check this out. If we go 1, 2, 3, 4, 5, 6, and over, well, it was over 2, wasn't it? Oh, man. So that puts us down there. Well, maybe this trick isn't going to work. Maybe this trick isn't going to work. And then half of that? So 1, 2, 3, 1. So you think it's going to be negative 7. So you think it's going to be negative 7. Anybody else think it's going to be negative 7? Well, 3 over 1 and 6 over 2 is the same. I think that's good thinking. Now let's go back to those tools. I did tell you that this is a tool that I like to have in my toolbox. Remember that? B equals y minus mx. Let's see if that confirms this. B is y minus mx. So what do I want to use for y? Do I want to use the 8 or do I want to use the 2? Doesn't matter. Take your pick. The 2? Okay. So b equals 2 minus m. We said m was 3. And in this case, then our x is going to be this 3, right? Okay. So what's 2 minus 3 times 3 is what? 9, and 2 minus 9 is... Hey! We got it. So you mean we can answer both of these questions, the last two, without even having to do any math? Yeah. Just with a picture. Sometimes you just got to look at it. If anybody follows me on Twitter, @themathoverlord, capital T, capital M, capital O, that's one of my that's in my profile. Sometimes you just got to look at it. I'd like to take this minute and give a shout out to my 6th period class for being so awesome on a Monday. I would take this time to tell a joke, but I can't think of any good ones. I could think of a rant. Earlier I talked about people operating motor vehicles. Turn signals, anybody ever not use them? That drives me nuts. Anyway, I better not rant too much. So they're talking about standard form of a linear equation. So let's go back to our tools. Maybe we need to clarify this business here. So back here, this is called standard form for the equation of a line. This is standard form. This is standard form for the equation of a line. Capital AX plus capital BY equals capital C. The weird thing about it is the X's go first, and then the Y's, and then equals, and then a number. When we get to chapter 3, which is going to be very soon, you're going to need to be able to put things in standard form. There's a reason we are addressing all this material. Okay. So I have a feeling the next example is going to do something with standard form. Let's see. Oh man, here it is. I'm going to put this on a brand new page. Hopefully that doesn't offend anybody. Do you guys know what your generation is called? What your generation is? My generation was Gen X. I know a lot of people from the Generation Jones. Anybody know what Generation Jones is? Generation Jones is a little bit after the baby boomers. You've heard of the baby boomers, right? Okay. Generation Jones is the ones that were keeping up with the Joneses, because after World War II, things in America, right out of high school, you get a nice, well-paying job and go to work and raise a family of like 17 kids on one income and live in a nice house and drive a nice car and not have to get a college degree to make a decent wage. Anyway, everybody wanted to keep up with the Joneses. The Joneses got a Cadillac, so you get a Cadillac. The Joneses get a Mercedes, so you get a Mercedes. The Joneses added an in-ground pole, so you add an in-ground pole, keeping up with the Joneses. Anyway, your generation is called the millennials. Did you know that? You don't want to know what they say about your generation. I hope you guys break the mold. I really do. I really hope you break the mold. They say your generation is easily offended. Every little thing offends you. Mr. Minnick, why did you put problem 3 on a new page? What's wrong with this page? Why couldn't you leave it there? I don't know. All right. So here we go. They want us to write this in standard form. So I'm going to recopy that. Y equals 3/4 of an x minus 5. They want this in standard form. Standard form is where the x's and the y's are all on the left. When I look at a expression, I look at terms. That's a term, that's a term, that's a term. Okay? That's how I identify things. Now, we want the term with the x in it to be on the left side of the equal sign. So when we bring that term over, what's that going to look like? What's the expression going to look like now? Nice. Negative 3/4 x, and then what? Plus y, and then what? Equals negative 5. Is everybody cool with that operation? Your algebra teachers might have said, well, you have to subtract 3/4 x from both sides. Yeah, you do, but I'm not going to show all that work. I'm just going to move the terms around and rewrite it. You picking up what I'm putting down? Good. So we probably ought to go back and say something about this tool. Speaking of tools, I have this one tool in my toolbox. It's really cool. It's got numbers on it. Anybody ever use a ratchet that has numbers on it? You know what they're for? Very precise work. If you're doing something where you have to tighten something to a certain specification, it's called a torque wrench, and you can dial up however many foot-pounds. Is that what you're talking about? The one with so like if you're tightening up lug nuts on a car, you don't want to over tighten them because you could snap them or not make them tight enough, and your wheel would fall off while you're driving, and that's not cool. So, anyways, if you don't know how to use one of those, you don't know how to use one of those. If you don't know how to use standard form, here's the deal: A, B, and C must be integers. They must be integers. A, B, and C have to be integers. When you're writing something in standard form, it only makes sense to use integer coefficients. And when it's all said and done, there are an infinite number of answers, even if those are integer coefficients. So to limit the number of answers, I'm going to take it one step farther. I'm going to say A, B, and C must be, new vocabulary word for you, relatively prime. It has nothing to do with West Virginia or Wyndham, so don't get offended, millennials. Relatively prime. Relatively prime. Anybody know what that means, relatively prime? I'm not going to write it. You might want to jot it down. Relatively prime means they don't have any factors. in common. They don't have any factors in common other than 1. So think about 3, 5, and 6. Are 3, 5, and 6 all relatively prime? 3 and 6 have common factors, right? But 3, 5, and 6, all 3 of them don't, so they're relatively prime. Okay. And one final thing, I'm going to say that A has to be positive. I'm going to say that A should be positive. So this way we're all going to get the same answer. This way we're all going to get the same answer. So A, B, and C have to be integers. They have to be relatively prime. And A has to be positive. Now we know how to use this tool. Now we know how to dial up the torque for our lug nuts. Anybody know the torque specs on lug nuts for most cars? Just an FYI, it's about 100 foot-pounds. About 100 foot-pounds. Walmart techs think it's 3,000. They think it's 3 million. Anyway, that's another story. All right. So we're looking good. We got the X's first, and then we got the Y's, and then we got an equals, and then a number. Houston, we have a problem right here. Nobody likes fractions. Nobody, and I mean nobody. Nobody likes fractions. All those dag-nabbit. I don't know why my highlighter's not working, but anyways, this -3/4, we gotta somehow make that not a fraction. Yes. Multiply by -4. That's a great idea. What made you think of that? It's got to be positive, and we want to get rid of the fractions. Now, somebody might have thought to themselves, well, let's multiply by -4/3. That would make that particular term not a fraction, but it would introduce other fractions. So -4 is awesome. Great. Great. So we're going to multiply everything in here, both sides of the equation, everything all at once by -4. So that's going to kill 2 birds with 1 stone, to use a metaphor. Hopefully that didn't offend anybody. Sorry, millennials. -4 times -3 is positive 12. And what's 12 divided by 4? 3. So the first term is going to be what? 3x. Awesome. 3x. -4 times positive y is going to give us what? -4y. And then -4 times -5 is going to give us 20. So that equals 20. Whoop, there it is. Now, I did give you another tool in your toolbox that you can use if you don't trust this, if you don't believe this. There was another tool in the toolbox that said y is -a over b x plus c over b. So if you don't believe that this is true, you could say, okay, is my slope -a? So that's -3 over 4. Is my slope -3/4? Well, yeah. Whoa, wait a minute. Over b, over -4. Is my slope 3/4? Yeah, my slope was 3/4. Is my y-intercept -5, c over b? My y-intercept, is it 20? Is it 20 over -4? Is it -5? Yeah, everything checks out. It's good. It's good. Do you see those other tools, why I gave you them? Okay. So to be clear, this is our answer. 3x minus 4y equals 20. Okay. Any questions? All right. Anybody want to give a shout out to somebody in one of the other Algebra II classes? Maybe you don't even know who's in there. Any shout outs? I might give a shout out to the future Mr. Minnick. He's probably sitting in the back taking notes. All right. You can graph an equation in standard form quickly by determining intercepts. They don't call this what I call this, but I like it. I like the fact that they are mentioning this. It's worth mentioning. 3x plus 5y is 15. So, guys, I'm going to let the guys in on a little secret. Maybe they know about it, maybe they don't. Anyway, one year for Halloween, I dressed up as a lady. And I was dating a girl at the time who was 6'2.5", and her mom was pretty tall. Her mom was 6'1", and her mom had monster feet. Her mom wore size 12 in women's, so I had some shoes to borrow. It was awesome. Anyway, I don't know if you know this, or some of the ladies maybe, if you're not buying your own makeup. Makeup is expensive. A woman will go into that one store out by the mall, and they'll come out with a little bag, and there's 3 things in it. What'd you get? Some cover-up, foundation, some powder. How much was it? $83. But I got this cool purse for free. $80 for 3 things? Yeah. Anyway. Or you could go to Rite Aid and steal it. No, I didn't say that. I didn't say that. That's why Rite Aid has the cameras up. That's why Rite Aid has all those cameras in the jewelry aisle or the cosmetic aisle. Okay. I'm not endorsing theft. Don't take that the wrong way. Sorry if that offended anybody, millennials. Sorry. Okay, the whole point of this is the cover-up technique. I love this. I love this. I love this. I love this. By definition, a y-intercept is the value of y when x equals 0. If x equals 0, I'll have 3 times 0, and this whole first term goes bye-bye, doesn't it? So 5y equals 15, so what's y equal then? 3, so what's my y-intercept then? 3. Y-intercept is on the y-axis. You with me? So my y-intercept would be 1, 2, 3. Boom. There it is. 0, 3. Does that make sense? Similarly, the x-intercept. The x-intercept is the value of x when y equals 0. So if y equals 0, that 5y term, it's going to be 5 times 0, that term goes away. 3x is 15, so what's my x-intercept? 5. 1, 2, 3, 5. No, I forgot. 4. 1, 2, 3, 4. 5. You know who messed that up for me? I'm going to blame you too. I'm blaming Bono. Because he says 1, 2, 3, 14. Why did he ever do that? Messed me up in the head ever since I heard it. I'm blaming Bono. Not taking responsibility for that one. All right. So here's my line. What do we have to do? Do we have to just graph it? There it is. There it is. That's it. That's it. Now, I know some of you are thinking to yourself, I don't have a graphing calculator. I'm not going to be able to do some of these. Well, how hard was that? Find an x-intercept, find a y-intercept, 2 points, connect them. Boom. Got it. There is a graphing utility that's free online. Anybody know the name of it? Desmos. D-E-S-M-O-S. Desmos.com. I would use it, but my computer and the internet, when I'm taping, they don't like each other. I think we're almost done. Drawing and interpreting a linear graph. The number of times, I remember talking to somebody about this. Did you guys know that the hotter it is, the more times a cricket chirps in a minute? Did you know that? So what happens if a cricket chirps 1,000,000 times a minute? Does that mean we're going to all blow up because the earth is melting? Well, the crickets don't affect the temperature, but the temperature affects the crickets, but that's a whole other story. So anyway, they want us to model this. The number of times a cricket chirps per minute depends on the temperature. Oh, it depends on the temperature. It depends on the temperature. So I'm going to have temperature either as the dependent variable or the independent variable. Which one's which? Temperature is going to be the independent variable, dependent variable. Which one's temperature? The number of times a cricket chirps depends on. So temperature is the independent, right? Okay. So then the number of times a cricket chirps. Cricket chirps. All right. The number of times a cricket chirps in 2 seconds for the 2 temperatures are shown at the table at the bottom right. All right. Oh, they already did this for us. That's cool. Get that out of there. Okay. Would you be able to interpret that graph? Would somebody sit there with a stopwatch and count how many times a cricket chirps for a minute? I would. If you wanted to know the temperature, does anybody know how to look at the sun at 3 o'clock and tell which way they're going in the middle of the woods? The Mayans? I do. I'm not Mayan. Where does the sun set? The sun sets in the west, right? So if it's 3 o'clock, the sun is starting to set. So wherever the sun is heading, wherever the sun is coming down from the top, that's west. Just follow the sun and you're going west. Which way is north? North is with respect to west, it's exactly 90 degrees clockwise from west. But you don't need math in the real world. Southern Ohio, you need math. There's no road signs in Southern Ohio. Anyway, that's enough of that. I think we're done. Oh, no, we're not. There's always more. Oh, man, how long does this go on? We got to be close. Wait, there's more. That's right. Slopes of parallel lines are equal. Slopes of perpendicular lines are negative reciprocals of each other. This is the last thing, I promise. So we'll do one more example with this, and then that's that. So slopes of parallel, and we talked about this last week, didn't we? Okay. Yeah, so you should have that in your notes already. Parallel lines equal slopes, perpendicular lines, opposite reciprocals. Here we go, last one. I'm going to have us do number B just because it's got fractions in it and just because fractions scare people. Here we go. The line perpendicular to this one. Ooh, so what should my slope be? Well, my slope, remembers the m. We're looking at the -4. I want something the opposite reciprocal of -4. So what should my slope be? 1/4. Now, how do you want to find the y-intercept? Do you want to use the b equals y minus mx, that tool that I gave you earlier? Or do you want to substitute into y equals mx plus b? Y equals mx plus b. Okay, so y equals mx plus b. Y equals mx plus b. So y is the 5. So 5 equals 1/4 times x. X is 8. Plus b. Plus b. I don't know what b is. I'm trying to find b. Oh, this is awesome. 1/4 of 8. That's 1 times 8 all over 4. Isn't that just 2? So 5 is 2 plus b. So b would be 5 minus 2, or b equals 3. All right. So our final answer on this one, our answer would be y equals what? 1/4 x plus 3. Now there's one little thing that I didn't mention, and I know I said this is it and this is it, but I gotta mention this. You gotta be careful how you write this. Y equals, the slope was 1/4, right? 1/4 x plus 3. You got to be real careful with how you do this. I know it seems like a subtle little thing, but if you write it like this, you know what the graph of that looks like? It looks like 1/4x, and have you ever seen the shape of that graph? It looks like this. Yeah. On the other hand, if you write it like this, the graph would look like this. So you really got to be careful how you write that. Really got to be careful how you write that. Okay? So you could write, to be safe, you could write x over 4. You could write x over 4. If you write your fractions slanty, probably a good idea if you have a fractional slope to put it in parentheses. Any questions? Comments? Concerns? Short debates, long debates? Well, that's it. It's real. It's fun. It's been real and it's been fun, but I don't know if it's been real fun. Have a nice day. See you next time. Good.